Hi everyone. Today we want to talk about how we learn and how we build cognitive muscle memory in the age of AI. In other words, how do we use AI to internalize knowledge and distill it into wisdom? We call this method driver. And it has 6 stages. First comes discover and define, then represent, then implement, then validate, then evolve, and finally reflect. I'll walk you through what each stage means. But first, let me tell you why this method exists at all. Here is the thing. In the age of AI, what we're actually learning for has completely changed. AI gives us a chance to rise above the old way and get back to what learning was always really about. For decades, most of what we called learning was really just memorizing, drilling, and testing. But with AI doing that heavy lifting, we can finally focus on internalizing. Instead, on building cognitive muscle, on turning knowledge into wisdom, on connecting what we already know with what we don't yet know, and letting AI help us fuse it all into something that is genuinely ours instead of cramming for a test and forgetting it the next day. So here is what I think. The age of AI has actually handed education a rare chance to get back to its real mission: shaping people, not just churning out employees, not reducing people to interchangeable cogs in a corporate machine. That is the whole point of Driver, bringing you back to what education was always meant to be. Internalizing knowledge, not just memorizing facts. Okay, let's take a closer look at what Driver actually is. Let's start with the first D, discover and define. Normally, when we learn something, we just ask, what does the teacher want me to learn today? Or what do I want to learn? But in Driver, that is not the question. The question is what task we want to complete. In other words, Driver is task-oriented, project-driven. The idea being that while you're completing the task, you naturally end up learning a ton along the way. And it is not just learning either. We've already applied that knowledge in the process, so it gets absorbed and internalized. That is how you build real cognitive muscle memory. So what exactly happens at this stage? Here is what we do. First, we define what task we actually want to complete. Then we discover what we already know. What else do we need to know? And if there are gaps, even gaps we don't know, we have. How can AI help fill them in? Through that back and forth with AI, we get a much sharper sense of the problem we're actually trying to solve. With that clarity, we're ready to move on to the next stage together. The next stage is represent. This is where we plan. We already know the problem from the last stage. Now we need the steps to solve it and the resources it'll take. We break it down into small steps, working backwards from the goal, a kind of reverse engineering, to map out the solution one step at a time. So represent lays out a path to the solution. Then we hand it to AI to carry out. That is the next stage, implement. Actually executing the plan. How do we implement it? Because we've already defined the problem clearly and worked out a solid plan up front at the implement stage. With how capable AI is today, it can usually pull this off really well, but we still need to watch closely. This might involve some coding, or it might not. When we walk through the example later, we'll dig into some of this in more detail. Once AI is done implementing, what do we do next? Remember, this is a learning method. We don't just call it done and walk away. Instead, we want the work itself to internalize the knowledge for us, to surface wisdom, the kind of insight that is hard to put into words. So how do we actually do that? We look at what AI actually did, which steps, which pieces it used. As humans, do we understand the logic behind it? And do we actually agree with the approach AI took to get there? We don't need to read every line of code, but do we understand the overall logic, the whole workflow? We're not hunting for syntax errors here. We're hunting for logical ones. Does this actually hold up in the real world? It is really a kind of reasoning practice. And in that process, while AI is doing the implementing, we stay close, watching for where things could be better. Once it is done, we verify the result. That is the validate stage. That is what validate is about. Most of our examples here live in finance and investing because finance has a particular quality to it. In finance, whether your data source is actually trustworthy is a huge part of what you need to validate. So, as humans, it is on us to validate the work. AI hands back. At this point, if all we cared about was finishing the task, we'd basically be done. But remember, this is a learning method, a way of training ourselves. So we don't stop here. We push further into evolve, expanding, and extending what we've learned. We ask ourselves, how could we have done this even better? Can we take what we just built and extend it into other areas? What is reusable here? And going further, what did we actually internalize this time? What changed in us? That is what we're doing at the evolve stage. And finally, after all of that, we get to reflect, a real honest self reflection. It is a bit like writing up a summary of the work. We ask ourselves, we just went through this whole workflow, solved this problem. Do we actually understand it? Do we understand it more deeply now than before? And how would we even prove that we understand this workflow? I think this kills two birds with one stone. We've completed the workflow, and now we have to figure out how to prove we truly understand it. Here is the method I'd suggest. Record yourself explaining the whole workflow and the logic behind it to the camera. Then watch it back and ask, did I really understand this? Because here is the thing. The act of explaining it out loud actually deepens your own understanding. If we never say it out loud, we can convince ourselves we get all of this, that we knew exactly what we did. But the moment we try to explain it clearly to a camera, it feels completely different. You'll uncover gaps and blind spots you never noticed you had. This is also huge for educators. If you're a professor today and your students are using AI for a lot of their homework, having them explain their work on camera in their own words is a genuinely great way to test real understanding. And of course, reflection isn't just about the workflow. We also reflect on the content itself, the whole process. Okay, I found these patterns, these phenomena. Can I actually explain them? Do they make sense from an economics or finance standpoint? Or do they seem to contradict what we know about how markets behave? And if something feels counterintuitive, can we still explain it? Or did we miss something? This whole process is deeply personal. It is your own training. And that is it. That is all 6 stages. Of course, driver isn't really linear. It is more recursive than that. In other words, you cycle back through these stages again and again. And that is the introduction to driver. Now let's walk through a concrete example. How we'd actually use driver to learn something and build real cognitive muscle. This is a pretty typical example from investing and finance. Quick reminder before we dive in. This is a demonstration of a learning method, nothing more. This is not investment advice, not here, not in any future video or lecture we make. We're only demonstrating how to learn, not telling you what to buy. Okay, let's dive into the example. Why investing of all things? Because investing is inherently forward-looking. Every decision you make is about the future, and the future is full of uncertainty. Everyone's goals are different too, so it is deeply personal, which makes this a perfect domain for practice. So let's get into it. If finance interests you at all, you already know the two things that matter most: risk and return. And every investor wants the same thing: low risk, high return. So I put that question to AI. I told it, I want to do some equity research. I think I need to find low risk, high return stocks. Here is what it said back. AI's response, not bad. Let's brainstorm this. It said this is actually a deceptively loaded goal. Generally speaking, low risk and high return. Those basically don't coexist in an efficient market. So if you want a high return, you have to take on high risk. That is the core idea behind the efficient market hypothesis. Let me pause here for a second. If I were a beginner and hadn't heard of efficient markets, this is exactly where I just ask AI to explain it. If you already know what an efficient market is, feel free to skip ahead. If you don't, the efficient market hypothesis basically says you shouldn't be able to find low risk, high return stocks at all. I don't fully buy that. I think it is still possible. What the theory really says is that across the whole market, at the macro level, it is very hard to consistently find low risk and high return together. But for individual stocks, one at a time, it is a different story. So I still went looking for that low risk, high return combination. Okay, let's keep going. As the conversation with AI went on, I realized there was a lot I didn't actually know yet. So I told AI exactly that. I want to learn the methods first. AI gave me a few options. Since this is a learning exercise, I picked the learn first option. So AI said, okay, let's start there. How would we even find a stock like that? Through that back and forth, one approach emerged. Look for a low peg. A low peg means the valuation is cheap relative to growth and non-financials. I didn't want a financial sector company, no banks. In other words, then mid-cap small to mid-sized companies, too small and the risk is too high, too big, and there aren't many opportunities left. Then I added one more criterion myself. AI hadn't brought this one up. Can we find companies where insiders management are buying the stock themselves? Insider buying is usually a good sign. AI said great instinct. That actually ties into the agency problem. The agency problem in finance is when management's interests don't line up with shareholders. If insiders are buying their own stock, that is a sign the two are aligned. I won't dig into all of that here, but AI handed me another idea right there. AI said, okay, so how do we actually find companies like this? We'd already framed a clear problem for AI. Find companies matching the conditions we just spelled out, right down to the specifics. Low peg, non-financials, mid-cap, and insider buying. Let's hand this off to AI and move forward. And this next part is actually where it gets interesting. We've arrived at the next stage. We know what we're looking for. AI's worked out how to find it. Now it is going to pull from some real data sources because I've got some financial data tools set up locally. Financial MCPS, data connectors, and one of them is called financial datasets. AI is going to query financial datasets using the conditions we just talked through. The ones we worked out together, it'll pull the data from financial datasets, then build the logic to actually make the selection. Turning our whole wish list of criteria into an actual filter, it can run against real company data, one condition at a time. So the first thing AI does is run a raw screen against financial datasets. No judgment calls yet, no cleanup. Just the four conditions we handed it, applied exactly as written, straight down the whole database. It takes these conditions and looks for matching companies, and it finds a lot of them, a genuinely long list, way more than I expected going in. But it also finds some specs mixed in with the real operating companies, okay? Specs. Say I'm new to finance and I've never heard of a spec before. That is another chance to learn right there. It also turned up closed-end funds and some ETFs. If you've never heard of some of these either, that is another learning opportunity. Go look them up later. But look at the numbers on them. their PEG ratios are really low, some of the lowest we've seen yet. On paper, every one of them looks like great growth at a great price. So, what is wrong with them? They're all special kinds of financial vehicles, wrappers around other assets, not real operating companies that make and sell something. That is why PEG doesn't mean the same thing here. I won't get into every reason why here. If you're curious, go look into these products yourself. The point is, they're not regular operating companies. They're financial products built to hold or track other assets, not businesses that make something and sell it. What we actually want are real, listed operating companies, the kind with actual revenue and real earnings. So we keep going. And here, AI starts correcting itself, filtering step by step, cleaning up its own first pass instead of just handing us the raw list. You can watch the whole reasoning play out right there on screen. Every condition it applies, one at a time, in order first. It wants revenue above $750 million. In other words, positive net income, a company that is actually making money, and it strips out the ETFs, the SPACs, the preferred shares, all of it, gone. Then it takes another pass because the first cleanup wasn't enough. There were some insurance companies still sitting in there. Technically, insurance isn't classified as a financial company the way banks are, so it slipped right through that first filter. But most insurers carry heavy leverage as just part of how the business works. That is baked into the model, not a red flag on their own balance sheet, but it still pushes the risk profile up. That doesn't fit our low risk condition, so those got removed too. There were also some mining and energy companies in the mix and so on, each one getting kicked out for its own reason. You can really watch AI's whole thought process here, step by step, condition by condition, honestly. It is a pretty inspiring thing to watch. Okay, let's keep scrolling. At this point, AI's landed on some genuinely interesting companies. Retailers. For instance, one sells cars. There are also some service companies mixed in there. These are now our real research targets, actual listed operating businesses with real revenue and real earnings. The kind we can actually dig into. This is what is left after 2 rounds of cleanup. And as you can see, this is step 2. That first pass is done, and a lot of companies got filtered out. Plenty we hadn't even thought to screen for at the start. So Represent actually did a lot of the heavy lifting here. All that screening, all that filtering, all that back and forth reasoning we just watched. That was Represent doing its job. Now we've got real candidates, and we've moved into implement, the actual execution, between Represent and implement working together. We landed on these candidates, and among them, AI flagged something interesting. Out of this whole shortlist, it said this is the one where we should take a closer look at PEG, the exact metric we built our whole search around. So let's use ABG, Asbury Automotive, as our working example. Let us look at its PE. Not bad at all. Relatively speaking, it is pretty attractive, around 6 times earnings, and the price to book ratio is actually lower than book value. Now, some people would say cheap for a reason, meaning the market's pricing in some problem we haven't spotted yet. We don't know that yet. So let's keep digging instead of jumping to conclusions. Looking at the PEG, EPS growth is strong here, about 30%. But notice that word grew past tense. Growth that already happened, already banked, already sitting in the rear view mirror. On its own, that number says nothing about what happens from here forward. So if you are looking purely backward, this PEG looks incredibly attractive. Low PE, strong growth. That is our first finding. Now the debt to equity, the debt ratio here isn't T-high at all. Around 12%. So that is step 2, done the valuation side of things, checked out, at least on paper. Now step 3, not what the numbers say, but what the people running the company are actually doing with their own money. Is management actually buying this stock? And yes, they really are. And digging into the insider buying data taught us something important. AI found 60 insider transactions total, but not all transactions are equal. Look at the type. The first kind, open market purchase, actually buying shares on the open market. Another type is stock compensation, RS, for instance. In other words, shares handed out as part of pay, not bought with anyone's own cash. Some are option exercises followed by an immediate sale, cashing out compensation, not placing a bet on the stock. Some are even outright donations of shares, more about estate planning than conviction. None of that really counts as a signal. Comp is comp. Exercises are paperwork. Donations are tax planning. AI flagged that only the open market purchase tells you something, because that is someone spending their own money with no obligation to do it. That is the one that matters. Is anyone actually doing that here? Yes, David Holt. He is the chairman and CEO, the person who knows this business better than anyone else in the world. He went into the open market and bought 5,000 shares of his own company as stock with his own money. And when did he do it? In March, at around $205 a share. Interesting on its own, one insider putting real money in, but there is also a board director buying on top of what the CEO already did. Two different people, both reaching into their own pockets for the same stock. This person bought quite a bit, about $1,000 worth. Then another purchase worth $29,000. So between the two of them, that is a real amount of money. The CEO is buying, and the board director is buying too. This could genuinely be a strong company. Quick recap. First, the PEG ratio is very low. Second, insiders are genuinely buying. So is this actually a good investment? So far, it is looking pretty good, but let's keep pushing. Here is the real question. If we want to actually verify what AI is telling us, how do we check? So here is what I did. I went to another site, Finviz. Let's pull up this company on Finviz. Let's cross-check what we found. Here is Finviz. Here is ABG. First thing, confirm it is the same company. Let's look at the peg here on Finviz. See how they build it. The forward P4E of about 6.7 divided by the earnings growth they expect over the next 5 years, which Finviz puts at just 5.2%. Do that math, and you land at 1.29. Not low, not even under 1. Okay, now flip back to our original number. Financial datasets handed us a peg of 0.21. That is 6 times cheaper than what Finviz is showing. Same company, same day. One source says it is dirt cheap. The other says it is fully priced. So where did that 0.21 actually come from? It came straight out of the financial datasets figures. But a 6-fold gap between two providers isn't something you just wave off. That is a red flag, no matter which one turns out. Right? So let's dig in and find out which number we can actually trust. Give me a second here. So I put it straight to the AI, something here isn't adding up. I am looking at Finviz right now, and it is telling me the peg is 1.31, but you gave me 0.21. Same stock, completely different answer. So I asked it point blank, why did you give me 0.21? And this is exactly where Validate earns its keep. AI went to investigate. It took a look at the Finviz data I'd sent over and compared the two. It actually ran a real validation, checking its own numbers against what Finviz was showing. One metric at a time, stock price matched. Price to sales matched price to book, matched price to earnings, matched to earnings. Matched to 4 for 4. So far so good. But PEG didn't match. The one number that actually mattered to us was the one that broke. And the reason comes down to how growth itself gets defined. Not some data error on either side. We actually just touched on this a minute ago. ABG's trailing 1-year earnings growth was strong, around 30%, looking purely backward at what the company already delivered over the past 12 months. That is the number of financial datasets used to build its peg in the first place. But the market, as forward-looking estimate for growth ahead is actually pretty low, only around 5%. That is the whole discrepancy right there. Trailing growth versus forward growth. Trust that the past predicts the future, and the peg looks fantastic. But the market's view, the consensus is that growth won't keep up going forward, that the pace behind that 30% simply isn't sustainable at the same clip. So from a forward-looking angle, the whole picture changes and peg jumps up. How high already above 1? This is what validate is for catching exactly this kind of thing. All the underlying data is technically correct on both sides. Nobody made an error, nobody's lying. It is the formula's perspective that is different. Trailing versus forward, and that is the whole story. Looking backward versus forward produces a genuinely huge swing in the peg. Enough to flip a stock from screaming cheap to fully priced, using the exact same underlying company and the exact same day's numbers. From a finance standpoint, we usually lean toward the forward-looking view. But honestly, who really knows the future? That is always the honest answer. AI can surface a discrepancy like this, but the judgment call is still entirely ours. Forward-looking or backward-looking. Only we can make that call. At the same time, whatever the peg debate settles into, we still see insiders actively buying with real money. A board director, and separately, the chairman and CEO both putting their own cash into this exact same stock at these exact same prices, buying their own company's stock with their own money, no obligation to do it. So as we just walked through from that first raw screen all the way to catching this peg discrepancy, the core workflow is essentially complete. So what comes after this? If this were just a work deliverable, we'd basically stop here, hand it to a manager and call it done. But this is a learning method, so we're not done yet. We push further after all this. How far can we take it? Let me give you two directions. First, we could turn this entire workflow into an automated screener. Build it into an app, run it weekly or monthly, and let it surface companies like this one automatically. Second, since we found ABG this interesting, I could go deeper on just this one company and build it a valuation model. I could use that model to test whether ABG at $201 is actually worth it, fairly priced or not, and from there decide whether I actually want to invest. So that is evolve. The last stage is really the heart of this whole method. Reflect. We need to look back on everything we just did. And if you teach, reflect matters just as much for you. As the learner, I need to close my eyes and really think back. What did I do? What did I learn? What actually got internalized? But if I only reflect silently, in my own head, I can talk myself into an illusion. The illusion that I've got this all figured out, feeling like I sailed through the whole process, like I understand every bit of it. So I have to test that. I'm going to sit down in front of a camera, turn it on, turn on the mic, and record, which is exactly what I'm doing right now. Obviously, a shorter, more focused version of it. I'm recording this to explain the whole workflow out loud, the internal logic, the reasoning behind every step. I want to walk through what I actually found about a company like ABG after running the full workflow. What did I find? What did I discover? Do these findings actually line up with economics and finance? If they don't, how do I push back on myself? Did I get something wrong? Or maybe it is something subtle and counterintuitive, something nobody else has caught. And we just did. So at this point, I said all of this out loud to the camera. My reflection, the logic behind the whole workflow as clearly as I could. By now, I feel like this round of training is essentially complete. Of course, we could always go another round. We could loop back through several stages again, represent and implement, especially tend to go back and forth a lot. and you've probably noticed with AI's help, we can move through represent and implement really fast. Okay, that is it for today. Quick recap. We did two things. First, I introduced you to this method, driver for training knowledge. Second, we walk through a real investing example to show you how to actually apply it. And one last reminder, this is a learning method, so it is going to be slow. It is not a way to get work done faster. The whole point of driver is to let you use AI to get things done while internalizing knowledge and building real wisdom. In other words, it is a method for building cognitive muscle, not a shortcut to easy work. In fact, this might genuinely be hard work, but that is what learning actually is. It is how you build inner strength. Okay, that is it for today. Thank you. If I get the chance, I'll put together something more in depth for next time. Goodbye.